What is dynamic equilibrium? Well, the word dynamic means motion. Now let's consider this system. There are 5 liters water present in this object. Now 1 liter water is entering into the vessel and 1 liter water is exiting. Now let me ask you, what about the total amount of water present in the object? Well, the total amount of water is still 5 liters in the object. Let me repeat it. The total amount of water is still 5 liters in the object. It is because the rate of entering water into the object is equal to the rate of exiting water from the object. I mean, if 1 liter water is entering to the object, then 1 liter water is exiting from the object. Hence we say that entering and exiting of water is in equilibrium. We know that water is constantly moving, so for the motion of water, we use the word dynamic. So this system is an example of dynamic equilibrium, where water enter and exit from the system, but total amount of water remain the same. To summarize this whole concept, we learn that if something is in dynamic equilibrium, the total amount like 5 liters water remains the same, but still there is motion, I mean like motion of entering and exiting of water. So note down this fundamental concept of dynamic equilibrium. Now let me teach you that what is chemical equilibrium. Well, consider a bottle of carbonated drinks. We know that in the bottle, the carbon dioxide gas is present in the space between the liquid and the cap. Now carbon dioxide gas will dissolve in water to form carbonic acid H2CO3. Secondly, carbonic acid will break down to form water and carbon dioxide gas. Hence we say that carbon dioxide moves from gaseous phase to liquid phase and then from liquid phase to gaseous phase. Now a time will reach when 10 molecules of carbon dioxide gas will convert to liquid phase, and at the same time 10 molecules of carbon dioxide gas will convert from liquid to gaseous state. But remember that the total amount of carbon dioxide gas remains constant inside the bottle. Here we say that the speed of forward reaction is equal to the speed of backward reaction, because 10 molecules of carbon dioxide gas convert from gaseous state to liquid state and 10 molecules of carbon dioxide gas convert from liquid state to gaseous state. Hence this point is called chemical equilibrium. Therefore, we define chemical equilibrium as when the rate of forward reaction becomes equal to the rate of backward reaction. This is called chemical equilibrium. Let me repeat it. When the rate of forward reaction becomes equal to the rate of backward reaction, this is called chemical equilibrium. Remember that at chemical equilibrium, carbon dioxide gas still converts to liquid phase and liquid carbon dioxide gas convert to gaseous state. We say that only their rates are equal. So this is the whole concept of chemical equilibrium. Now let me teach you why chemical equilibrium is called dynamic equilibrium. Well, consider previous examples of carbonated drinks. We have learned that carbon dioxide gas converts from gaseous state to liquid state and then from liquid state to gaseous state inside the bottle, and the total amount of carbon dioxide gas remains constant inside the bottle. Now a time will reach when the speed or rate of forward reaction becomes equal to the rate of backward reaction. We know that this is called chemical equilibrium. Also we have learned that the word dynamic means motion. Now let me ask you, is there any motion of carbon dioxide molecules at chemical equilibrium? Well, your answer is yes. Gaseous molecules of carbon dioxide convert to liquid state and liquid molecules of carbon dioxide gas convert to gaseous state. So this motion of carbon dioxide gas is happening at equilibrium. Hence, we also call it dynamic equilibrium. Thus, every chemical equilibrium is also called dynamic equilibrium. Let me repeat it. Every chemical equilibrium is also called dynamic equilibrium. If you ask me why, the answer is simple. It is because particles of reactants and products still move from one phase to another phase. Finally, let me teach you some exam question. How can you explain that these reactions are in dynamic or chemical equilibrium? Well, 1 mole of nitrogen gas plus 1 mole of oxygen gas react together to form 2 moles of nitrous oxide. Now, nitrous oxide will break down to form 1 mole of nitrogen gas plus 1 mole of oxygen gas. When we say that this reaction is in dynamic equilibrium or chemical equilibrium, it means that the rate at which nitrogen gas plus oxygen gas react together to form nitrous oxide is equal to the breakdown rate of nitrous oxide to form oxygen gas plus nitrogen gas. Secondly, in this chemical reaction, 1 mole of nitrogen gas plus 3 mole of hydrogen gas react together to form 2 moles of ammonia gas NH3. At the same time, 2 moles of ammonia NH3 gas break down to form 1 mole of nitrogen gas plus 3 moles of hydrogen gas. When we say that this chemical reaction is in chemical equilibrium or in dynamic equilibrium, it means that the rate of forward reaction is equal to the rate of backward reaction. I mean, the rate at which nitrogen gas plus hydrogen gas react together is equal to the rate at which ammonia break down to nitrogen gas plus hydrogen gas. Thus, this is the whole concept of chemical equilibrium and dynamic equilibrium.